So today I wanted to talk about AVL trees. AVL trees are a type of binary trees. They have a bounce factor and rotation. So here's a binary tree, for example. So here the height would be considered log n. But the issue with binary trees is the order of which the keys are placed. So again, I'm gonna create a tree, binary tree, with the same keys but in different order. You can see now the height becomes n, which is linear, and that's not what we want. So how AVL trees fix this is they have rotations. But to do the rotations, you first need a bounce factor. So AVL trees have a bounce factor that's the left height of the subtree minus the right height of the subtree. The bounce factors can be plus or minus 1. Anything greater or less than, a rotation must occur. So here's an example of a left-left rotation. So let's check the height of these three elements. So as you can see, our first element is unbalanced. So how do we rotate this tree? That's how we can rotate a left-left imbalance. What about a right imbalance? And now our heights are balanced. What about more complex rotations? Let's take a look at a left-right rotation. So our first goal is to try to get it in the same direction as the first component, which is left. And then we can just simply perform a left-left rotation. And that's how you'd solve the right-right rotation. So let's insert these trees. Here you can see we have a left-left imbalance, so we're going to do a left-left rotation. A neat trick for the naming scheme is just take a look at where they're positioned. This is left, left, so that's why we do a left-left rotation. Now let's insert 30 and 35, and now we have another imbalance. So when taking a look at imbalances, we should look at the tree or the leaves up, so that it's a left-right rotation. And again, we'll continue. And now you can see our entire right subtree where 35 is happy, but 25 isn't. Right now, 25 has a bounce factor of minus 2. So how do we fix this? Again, we perform the rotation on the grandchild. So we'll take these elements and perform a left-right rotation. Those are some of you might lose it, and it might be a little difficult, but you can think of it like this. The entire left subtree, from removing 30, what do we have to do in this situation? We're doing a left-right rotation, right? So we're going to move 30 to the same direction. So 25, 30, 35, and then we have to move 30 up to the center. And we simply follow those leaves and attach them back to where they were. And next, let's attach the last leaf, or last value, 75. Looks like we don't have to perform any rotations because our whole subtree, or entire tree, is balanced. And that's how you insert and do rotations on AVL trees.